here we have some logarithmic equations that we're trying to solve. And we're going to do that mainly by converting them to exponential form. In this first one, we have the log base x of 1 over 125 equals 3/5. And remember, what that means is x, the base, raised to this power equals that. So we can just write it that way. X to the 3/5 power equals 1 over 125. Now we want to solve for the value of x here, so we have to undo this raising it to the 3/5 power. The way to do that is to raise that to its reciprocal power, so I'm going to raise that to the 5/3. Remember, when you raise a power to a power, you multiply, and you can see if you multiply 3/5 by its reciprocal, you're going to get the power of 1. So this just becomes x. Of course, we have to do the same thing over here, raise this to 5/3, and that's not too tough. I would take the cube root of 1 and 125 first. That would be 1 over 5, and then raise that to the 5th power, and you would get 1 over 3,125. So that first one's not too tricky. Let's look at another one. This one says log base 5 of 3x plus 8 equals 4. Let's go ahead and write that in exponential form. It means 5 to the 4th power equals this. And 5 to the 4th power is 625, and we have a simple algebraic expression or equation here to solve. So we subtract 8, and we get 617 equals 3x. We divide by 3, and I think I'm going to leave it there. You could figure out the decimal for that if you'd like to. It's 200 something. All right, let's look at this next one. So we've got the log base 2 of x plus 3 minus the log base 2 of x equals 6. So this one's a little bit more complicated. What we're going to have to do here is apply one of the properties of logs that we know, and that is that subtraction, as long as the bases are the same, can be rewritten as division. So this part right here equates to log base 2 of x plus 3 divided by x. So the subtraction becomes division. That all equals 6. Once we get it here, we can pretty easily write it in its exponential form. So we'll take the base of 2, raise it to the 6th power, and set it equal to that. So 2 to the 6 equals x plus 3 over x. And let's see, 2 to the 6th is 64 equals x plus 3 over x. And we can multiply both sides by x, and we get 64x equals x plus 3. Subtract an x from both sides, we get 63x equals 3, and then divide by 63, and we get x equals 1 over 21. Whoops, there it is. All right, a couple more. Here's another one that looks a little bit more complicated. This time we have addition instead of the subtraction of our logs of the same base. And you should remember from our log properties that this can be converted to multiplication. So I can rewrite this left half of the equation as log base 2 of this times this. So actually, let's go ahead and do the multiplication right now. I'll FOIL that out. So that would be x squared plus 6x plus 8. So that is the same thing. Log base 2 of that is the same thing as these two logs added together. So that's going to equal 3. Now we can put this in exponential form, so we'd have the base 2 to the power 3 equals this guy, x squared plus 6x plus 8. And then we can subtract, well, 2 to the 3 is an 8, so we can subtract 8 from both sides here, and we get 0 equals x squared plus 6x. From there we can factor out an x. We get x times x plus 6. So you see we're going to have two factors here. 1 equals 0 and 1 equals negative 6. You do want to ask yourself a question at this point, and that is, do both of these solutions make sense? If you put in a 0 for x up here, you'd have the log base 2 of 4, you'd have the log base 2 of 2. Both of those make sense. If you put in a negative 6, you'd have the log base 2 of a negative 2 in here. You'd have the log base 2 of a negative 4 in here. There isn't a power you can raise 2 to get a negative 4 or a negative 2. So the negative 6 just doesn't make sense, and we're going to chuck that out. So our one answer is 0. All right, last one. We've got a word problem here. This one says the number of a certain product that will be sold t years after the product is introduced is given by this function. N of t equals 8700 times the natural log of 8t plus 7. How many years after the product is introduced will 36,000 be sold? So the function tells us how many will be sold. So this 36,000 is going to sub in for n of t. We're looking for how long, time, and that's the variable t, so we're going to try to solve for t there. So let's see how to do that. We'll set this up first. So here's our 36,000 subbing in for n of t. Then we've got 8,700 times the natural log of 8t plus 7. So somehow we want to get at that t that's inside those parentheses. The first thing I'm going to do is undo the multiplying by 8,700. And we'll divide both sides here. And let's see, if you divide 36,000 by 8,700, I think you get 4.138 or so. And then we've got the natural log of 8t plus 7. Now, to get at that t inside there, I have to undo the natural log. The way to undo a natural log is to take e and put e to this power. So I'm going to do that to both sides. I'm going to set the left-hand side to e to the 4.138, and I'm going to set the right-hand side to e to the natural log of 8t plus 7, which these two things undo themselves, so that really comes out to e to the 4.138 equals 8t plus 7. And at this point, you would want to plug in e on your calculator, raise it to this power, subtract 7, divide by 8. What you end up with, if you do all that, is approximately 7 years. You can check my math on that one. So that's a little bit of work with some logarithmic equations.